Exercise 8.3, Problem 1, Discussion. A plate top is in the form of a hemisphere surmounted on a cone. The diameter of the hemisphere is 3.6 cm. The total height of the plate top is 4.2 cm. Find its total surface area. Looks a little complicated, so let's draw the figure. Okay, so if you see, this is a hemisphere sitting on top of a cone. Okay, it's a typical plate top. So this is what they mean to say when they say, this is what they mean when they say a hemisphere is surmounted on the cone. The hemisphere is sitting on top of a cone. Okay, the diameter of the hemisphere is 3.6 centimeters. Okay, so that is the diameter of the hemisphere. This is 3.6 centimeters. That's what we say here. This is 3.6 centimeters. But if you look at it, the diameter of the hemisphere is also the diameter of the cone. Okay, so both the diameters are 3.6 centimeters. Then they say the total height of the plate top is 4.2 centimeters. That is, from here to here is 4.2 centimeters. But what is this? This is the height of the cone plus the radius of the hemisphere. So h plus r is equal to 4.2 centimeters. So that is what is given in the problem. So let's write diameter d equal to 3.6 centimeter, capital H, that is a total height, is 4.2 centimeters. Anything else? I guess that's all it is. Then what are we asked to calculate? We are asked to calculate the total surface area of the plate top of the hemisphere as well as of the cone. That's the total surface area. So now let's write a short hint. Actually, let me a summary or a hint which we will write it out here. The total surface area of the plate top is the CSA, curved surface area of the hemisphere, plus the curved surface area of the cone. So this is what is the total surface area of the cone. Sorry, of the plate top. Okay, because it's got a hemisphere as well as it's got a cone. So the sum of the curved surface area of the hemisphere and the cone is the total surface area of the top. So that is equal to curved surface area of the hemisphere is 2 pi r square. Curved surface area of the cone is pi r l. So you can take pi r commonly out, pi r into 2r plus l. You can do it this way, or you can do individually calculate the hemisphere CSA, curved surface area of the cone, and add it. Whichever way it suits you, you can do. But we are doing it this way here. Okay. So let's write the formula. The formula: total surface of plate top is pi into r into 2r plus l. We just did that calculation here. Okay. But if you look at this, we want to calculate TSA, but we don't know r, we don't know l, which means we cannot use this formula as of now. So we'll have to calculate L as well as R. So let's do L. L is root of h square plus r square. Again, we cannot use this because we don't know h nor r. But now we come to this formula. Total height is h, height of the cone, that is total height is height of this cone plus the radius of the hemisphere. So h plus r. So we know the total height 4.2 centimeters. We know the radius. We should be able to calculate the height. Okay. Then actually it's not known here. It's in the next step only we know. So d equal to 2r. The diameter 3.6 centimeter is the equal to 2r. So from this, d is known, r can be calculated. Once r is known, you can calculate total height. Once total height, we can calculate height. Once you know height, you can calculate slant height because h and r is known. Once you know h and r, you can calculate TSA of the plate top. Okay. So let me just, this is also not known at this stage. Okay, it should be in that reddish maroon color. It's a mistake, we have made it green. Okay, so you start from radius. So first you calculate the radius from the diameter. From this 3.6 centimeter, calculate the radius of the hemisphere, which is also the radius of the cone. Then use that in this formula and get the height of the cone. Once you get the height of the cone, calculate slant height. Once you calculate slant height, you can calculate the TSA. Okay, let me summarize the steps. Calculate the value of the radius of the hemisphere and the cone. Both are the same. Okay, using d equal to 2r, that's equal to 3.6 centimeters. So radius will be 3.6 divided by 2, 1.8 centimeters. Step 2. Calculate the height of the cone using total height equal to h plus r. The total height is 4.2 centimeters. So 4.2 will be equal to h plus r, which you have calculated 1.8. So from which you can calculate the height of the cone. Next, you calculate the slant height using root of h square plus root of r square. H we calculated in step 2, r we calculated in step 1. So we should be able to calculate L. Once we know L, substitute the values of r and L in the formula TSA equal to pi r into 2r plus L and calculate the TSA of the plate top. That's all it is. As I said earlier, you can either use this formula or you can use this curved surface area of the cone of the hemisphere plus curved surface area of the cone individually and add it up together. All I have done is I have taken pi r commonly out in this formula. Whichever way suits, you can do it. Okay. So let me pause it here. You try to understand the steps clearly and try to work it out your own. Then come back and check you're working against our solution. Now let's look into the solution. The diameter is 3.6 centimeter. Total height is 4.2. We know the total surface area of the plate top is curved surface area of the hemisphere plus curved surface area of the cone, which is 2 pi r square is the curved surface area of the hemisphere. Curved surface area of the cone is pi r L. We can take pi r commonly out. It becomes 2r plus L. Okay. Now for the hemisphere, it's better you do bit by bit individually. D equal to 2r, that's equal to 3.6 centimeters. So r equal to 1.8 centimeter. For the cone, again d equal to 2r only. 2r is a common, but it's the same 3.6 centimeter. As I explained earlier, this is 3.6 centimeter, which is the diameter for hemisphere as well as for the cone. So the diameter for the cone is also 3.6 centimeter. So radius of the cone is also 1.8 centimeter. 3.6 divided by 2. Now total height is given. So h equal to total height minus r. So h will be equal to 4.2 minus 1.8. That's equal to 2.4. I hope you remember the total height is this. And from that you subtract the radius. You will be able to get the height of the cone. So height of the cone is total height minus r. Now we have the radius of the hemisphere, we have the radius of the cone, and we also have the radius, height of the cone. Okay, come back. Slant height of the cone is root of h square plus r square. Substitute the value of h, which is 2.4, and r is 1.8. You'll be able to get r is 3 centimeters. Okay. Now substitute the value of r, which is 1.8, and L, which is 3 centimeters in equation 1. For simplicity, I have written it here because it is in the previous page. So TSA is pi r into 2r plus L. So pi into r is 1.8 into open bracket 2 into 1.8 plus 3. So that will be 1.8 pi plus 1.8 into 2 is 3.6 plus 3 is 6.6. So that gives us 11.88 pi centimeter square. So the TSA of the plate top is 11.88 pi centimeter square. Okay, one note of caution is we have taken r commonly out. Okay, and this is because the hemisphere as well as the cone have got the same r. If they are different, then we should not use this combination method. Okay, that's all it is here. So please check you're working against this solution, and if there is any difference, please correct it. And if your concept is not clear, please go back to the discussion part of the video, review it, and get your concept clear. Thank you for watching.